everyone, welcome to Design Technology Tutor. Today we're going to be going through the GCSE AQA Design Technology Specification for the grade 9 to 1 course. So how this works is each video will delve into a different topic of the specification. So let's begin. Today we're going to be discussing technology in manufacturing. Manufacturing is a system. Industry involves manufacturing products, and manufacturing involves several processes that are carried out to create a finished product from some raw materials. For example, metal, textile, and paper. The process of manufacturing is a system, and products are made as a result of a number of different stages taking place one after the other. And these systems can be split into 3 different parts, so let's look at that now. So your first stage will be the input, and this is all of the materials, tools, and equipment that we start off with. Secondly is the process, and this is what happens to the input to change it into an output. For example, measuring, cutting, and forming processes. And finally is the output, which is the result of the system. In other words, the finished product. So let's talk a little bit now about advances in technology and how they can improve manufacturing. So technology never stands still, and advances can help manufacturing processes to run more efficiently. And in recent years, this is enabled particularly by advances in information and communication technology. So firstly, we can delve into automation of manufacturing processes. So automation is the use of machines to do a task automatically. The clue's really in the name, without much or any human input. For example, all a human would need to do is press a button and a robot or a machine would carry out the whole entire process from start to finish. Automation has been a key development in manufacturing and is present in many modern factories. It can be used to carry out a particular process or manufacture a whole product. For example, in the car industry, robots are used to do certain processes like welding parts together and stamping out metal body parts. These robots are programmed by humans but are then run automatically, and humans are only needed to monitor the robots and repair them if they are broken down. Robots are continually being developed to be more intelligent and to allow them to work more closely with humans. For example, robots exist that can be easily programmed by humans and can then learn how to do a task after being shown it by a human worker. This worker can then supervise the robot. It is hoped in the future that factory robots will be developed that can deliver consistent and accurate work as they do now, whilst also having some of the characteristics that only human workers currently offer. For example, the ability to make judgments and come up with their ideas or problem solving. Now, as with all advances in technology, automation of manufacturing processes come with its advantages and disadvantages. So let's have a little look at them now. So robots can increase the speed of production as they can work faster than humans and don't need to rest. This also means that robots can be cheaper to use than human workers. Robots can work with high accuracy as they perform the same tasks consistently, whereas humans can make mistakes which have costs, example, time and materials. Robots can therefore increase the quality of manufactured products and reduce costs. Robots can also be used in dangerous situations where it would be unsafe for human workers. Let's look at some of the disadvantages now. So robots can replace human workers, so that means there are fewer jobs for people to do. They can also be very expensive to buy, and robots cannot carry out tasks that require human judgment. Another advance in technology in manufacturing is smart technology. There are many examples of computerized machines that have been designed to carry out advanced tasks accurately. For example, CAD and CAM processes. Smart technology develops these machines further by connecting them with other machines and sensors in the factory so they can share data. These smart materials can use this data to help organize which tasks they need to do, without any human input. Smart materials can also help receive data about stock levels and work out when they'll run out of the materials and components. Smart machines can be a part of the Internet of Things, and this describes the connection of loads of different machines, devices, and other bits of technology to the Internet. For machines, this could involve receiving and processing online customer information. This use of smart technology can make automated manufacturing extremely efficient. Another advance in technology is communication system. In modern automated factories, information can be passed around by smart machines, so communication requires no or little human input. Human workers can also use telephone, email, and video conferencing and other internet-based communication systems to share information. Workers can also use devices to receive information. For example, warehouse workers can use a device like a tablet or a phone to direct them around the warehouse in the most efficient route to collect items in customer orders. Let's look now at some specialized buildings and how they can help improve manufacturing processes. So new technology means that factories are being designed to incorporate smart technology and also to minimize the environmental impact. For example, using new water recycling systems to reduce water waste. Factories can also be made of modular components that can be taken apart, moved, or added to. So you can have extra production space that can be added if needed. Technological advances are also leading to a reduced need for room. For example, the increased use of robots and automation means that factories can take up less space. 3D printing is a new advance in technology that can use a smaller machine, so manufacturing can move out of larger factories into smaller local spaces, which can save and reduce costs. Tracking of materials, tools, equipment, and products. Factories contain materials, tools, equipment, and the products themselves, both finished products and those that are partly made. Tracking of these items has been a key development in recent years. This can be done automatically by tagging each box of material, tool or product, etc. These tags can then be scanned or detected as the item moves around the factory and the status of the item is kept up to date in a computer system. Tracking the location of items has many uses. This includes monitoring the stock levels of raw materials and components, the movement of products around the factory as they are being made, and the number of finished products in stock. So tags can be used or detected by wireless signals, which can help reduce lead time and manufacturing time. Now that we have discussed advances in technology that can improve manufacturing, let's look at the different ways of manufacturing that can help maximize efficiency. Let's talk a little bit now about flexible manufacturing systems, or FMS. Flexible manufacturing systems consist of a set of different machines which carry out the different stages of production. These computer-controlled automated systems transport materials through the different processes and eventually store the finished product. They're called flexible because they're easy to adapt, and it is fairly quick and straightforward to change the system if the design of the product being manufactured is altered. For example, the layout of the system can be changed and new machines can be added. These systems are also easy to alter if the level of production changes. For example, machines can be added to the system to boost production. Another method manufacturing can help maximize efficiency is the use of lean manufacturing. So lean manufacturing comes from a Japanese approach to manufacturing that aims to minimize the amount of resources used and the amount of waste produced. The aim of lean manufacturing is to minimize costs and maximize efficiency. The just-in-time or JIT system of stock control is a form of lean manufacturing. Materials and components are delivered as they are needed and is used as soon as they are delivered. It's important to note that waste doesn't just refer to materials, it includes things like unnecessary use of time, transport, and movement of people, and other examples. Let's look now into the different advantages and disadvantages of just-in-time systems. One advantage is that it reduces the amount of space needed for storage of materials and finished products, which in turn saves money because you don't need to rent out huge warehouses. It also means that there is less money being tied up in materials that aren't being used. So a disadvantage of JIT is that the system relies on materials and components being delivered on time and being fault-free. There isn't enough time to return faulty goods, and if these two things don't happen, money can be lost. which isn't good for a business. And we've come to the end of the video. I hope you found this one useful as you prepare for your GCSEs. But for now, that's all from me, the Design Technology Tutor, and I'll see you in the next one. Good luck.